A long, long time ago, there were cavemen. And these cavemen were not just your average grunting folks like hunting animals and dancing. No, they were thinkers, ponderers, puzzlers. And most importantly for us, they were rock collectors. Yes. One day as they sat around their cave looking at their shiny rock collection and wondering how many rocks do they have, the first seeds of math were planted. This moment marked the birth of numbers. At first it was simple. They used their fingers, then toes, and soon enough rocks themselves became counting tools. As civilization rose, math evolved with it. The Egyptians used math to build their pyramids, creating geometric wonders and yes, large cats. The Greeks took it further with geometry thanks to Pythagoras and his right-angled triangle. Fast forward, we get Isaac Newton and the legend of falling apple. Together with Gottfried Wilhelm Leibniz, independently derived one of the most important tools in modern math, calculus. With calculus, we could tackle problems once thought impossible. We could calculate areas under any type of curves, understand the rate of change. And then came Descartes. He figured out a way to visualize equations on graphs known as the Cartesian coordinate system. Then came another genius, Leonhard Euler. He brought his unique genius to nearly every area of mathematics. He laid the foundation of graph theory, and he did that just by looking at bridges. Yes. The 19th century brought Carl Friedrich Gauss, the prince of mathematics who dived deep into number theory and statistics. Things get really interesting in the 20th century. Cantor explored the infinite with set theory. Turing broke codes and laid the groundwork for computer science, and Noether revolutionized algebra. Chaos theory then entered the scene, proving that simple systems could produce complex behaviors. The journey that began with cavemen counting rocks has taken us to counting the fundamentals of this universe. So next time when you solve a math problem, remember you are following in the footsteps of those cavemen who dared to ask, how many rocks? But what about the history of physics? Is it related to math or completely different?
What causes day and night? Why do stars twinkle? Why does everything fall to the ground? These questions have fascinated people for ages, sparking the study we now call physics. Aristotle, an ancient Greek philosopher, coined the term physics from the Greek word physis, meaning nature. For centuries, physics was about thinking deeply and pondering nature's mysteries. However, in the 17th century, Galileo Galilei changed this by introducing the scientific method. Galileo's approach focused on observing and experimenting. From establishing the concept of inertia and relativity to confirming the heliocentre model of solar system by Copernicus, his ideas challenged the old beliefs and set the stage for modern science. Building on Galileo's work, Sir Isaac Newton wrote Mathematical Principles of Natural Philosophy, which clubbed mathematics and physics together. Newton's universal gravitational law was groundbreaking as it opened avenues for celestial physics. There was an even greater push to celestial physics with the development of telescopes. Telescopes helped us learn more about light, leading to debates over whether light is made of particles or waves. These discussions led to the advancement in electromagnetism and thermal physics. In the 19th century, James Maxwell formulated the famous Maxwell's equation, which describes how electric and magnetic field interact. This unified our understanding of electricity, magnetism, and light. Around the same time, scientists like Rudolf Clausius Maxwell also developed statistical physics, explaining how large group of particles behave. This helped us understand heat and gases better. In the earlier 20th century, Albert Einstein revolutionized our understanding of physics. He developed the theory of general relativity, which explained the effect of gravity on large scale, like bending of light by gravity and orbits of the planets. Einstein also gave the theory of photoelectric effect and showed that the light behaves like particles, leading to the development of quantum mechanics. Quantum mechanics further developed by scientists like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger revealed the strange and fascinating behavior of particles at very small scales. Louis de Broglie proposed that both light and matter have wave-particle duality, shaping the quantum model of the atom. Today, quantum mechanics has led to incredible advancements, including quantum computing. Quantum computers use the principle of quantum mechanics to perform calculation much faster than the traditional computers. This has given rise to potentially revolutionized fields like cryptography, medicine, and artificial intelligence. Physics shows how the nature works and makes our lives better. In the word of Richard Feynman, physics is the way to understand how the universe works at its deepest level. Embrace the study of physics and you will uncover the beauty and elegance of nature's laws.